Alright, hello everyone, this is Mr. Crouch. I'm going to go over quiz 1A from Khan Academy and for your final. First thing, which of the following functions are continuous for all real numbers? Well, all numbers go into this function, and if you were to graph it, it's going up. However, you cannot put negative numbers into this function. The graph of this function is only defined for positive numbers. So this one is not continuous for all numbers. Negative numbers are not a part of that. F only. Number 2, find the limit as x goes to pi. Well, what you need to do is think about this graphically and what's happening at the number pi. Well, that's on both sides. Over here is the left version. Here's the right side of pi. On the right side of pi, we use this. On the left side of pi, we use this. So plug in pi, and you will see they match. They both go to 0. Number 3, the function right here is defined for everything but 6. What's the limit? Well, both sides of this, left and right, are going to about 2.7. Up here, they're going to 0. Here, they're going to 2.7. The function here, well, if we graph this, if you put this on your calculator, there is an asymptote at 3 because it cannot be removed. And then if you plug in numbers on this side of 3, they go up to infinity, and this side, they both go up. This denominator is getting squared, so everything goes positive up that way. You can graph it on your calculator and see. Let's get a quick view of this. Let's see here. I'll clear that out, and I'll put in 2 divided by the parentheses x minus 3 squared, graph, and right there at 3, both of them are going up. On this one, if you take this, factor it, then you can plug in 3. You can't, sorry, negative 3. You can't plug in negative 3 here because it will be a 0 denominator, but you can factor it and then plug in 3 there. The limit here, if I put in infinity, well, on the numerator, I have infinity plus 1. On the denominator, I have infinity squared plus 1. Well, this bottom is much larger than the top. It's going to go to 0. Another way to see it is let's just talk about the front terms here, and we have x over x squared, which would just be 1 over x, which would be 1 over infinity, which would lead to 0. And if you graph this too, again, if you graph this, the end behavior is going to go out to 0. Number 7, the end behavior here is it's going to negative 5 to negative infinity, to positive infinity, it's going to 3. The limit here, where are these numbers going? If I were to draw a line at 3 right there, well, what is really close to this? Well, that's 10. On this one, is the function continuous? Again, imagine that you are trying to figure out what's happening at this graph at point 3. Well, on the left side, it's coming down to 2 because I put a 3 in there, so it's coming down to 2 here. On the right side, it's also coming down to 2. So yeah, it is continuous. They go together, they match at 3. Number 10, plug in negative 1, it directly substitute. Negative 8 divided by negative or by 2 is negative 4. Always try to do direct substitution. If you can sub it in, that's your value, that's your limit. Number 11, what's a reasonable limit for 0? Well, on day 0, it's 2 different points. On the left side, it's going to 5. On the right side, it's going to negative 5. They don't meet. There's no limit. Take a look at this one. On this one, they're both going to 10. They are going to 10. Here, they're going to 2 different things. The limit does not match. All right, this is a function, but I just want negative 8 from the numbers that are on the right side. So here's negative 8. I want to know what is the graph doing this way. So I ignore all of this and I just say, what is it doing on the way to 8? Well, it's at 8, but that's not where it's going. Look, it's 0.2, 0.04, 0.08. This keeps getting smaller and smaller to 0. It's going to 0. All right, hope this helps with your study of limits.